how's it going? I hope you're well. In the previous video, we got GLFW to create a Windows surface which sort of configured for Vulkan. So now the Vulkan API has a surface that it can write to, and that surface will appear on our window, in theory. Now, another thing that I need is I've got a surface that I can present to, I can write to. I need to create what's called a swap chain. What is a swap chain? Well, the big concept of Vulkan is that in the past, OpenGL was an asynchronous device or an asynchronous API that was designed to look like a synchronous one. What we had is we went ahead and drew something, and the resources which we were drawing had to really only exist at one point in time. We go, okay, here's the buffers and the images and everything that we're going to use. Go ahead and draw. And then after we issued that draw call, we could sort of forget about it. And the reason for that was that draw call was monolithic and it had tricks. It was doing tricks. But now it's exposing to us the full capabilities of its asynchronicity, and there's sort of an infinite extent to the sadomasochism you can subject yourself to in getting, shall we call, creative solutions up. But let me bring that back to the concept of a swap chain. So a swap chain is a collection of images which are sort of like in a holding pattern. We can take an image, we can render to that image, and then that image sort of stays in memory, ready to go, ready to be presented to the surface, ready to be blitted onto the screen. But if we were to then grab another surface and start rendering to that surface while one surface is being presented to the screen, we very well can't do that to the same image. We can't have the same memory that we're modifying for that. And that is the basic idea of a swap chain. And this is probably a good time for me to talk about another big concept, which is duplication of resources. So if I go over, as with all of this, I can't 100% do it from scratch because it wouldn't be interesting. It would be a lot of coding. But what I've got here is I've got a class called a frame, and this frame class will hold all of the resources which will be used in one full rendering and presentation operation. So later on, when we have like a game system up and running, that game system might have a whole bunch of objects. Those objects might have a whole bunch of positions. And what we want to do is we want to take a snapshot of all the positions of the objects at the current moment in time, save that to a buffer, and then when it comes time to render the graphics, take that buffer, use that buffer, read from it on the GPU to render everything, and then that thing gets rendered to an image, and then when it's time to go, when it's time to present, that image is presented to the screen. So we need to have a whole bunch of independent lifetimes, and the same way that a swap chain is a bunch of independent lifetimes, so is the info needed in rendering. And so, at least to my way of thinking, it's a pretty natural pattern to bundle these resources together in a frame. Currently, it's just an image, and that image is coming from a swap chain. Perfectly fine. Okay, so just for the purposes of completeness, we can have a look at the frame source file. And again, its constructor just takes in an image. All it does is saves that image. Pretty much what I would expect. So let's now have a look at the renderer. Pretty similar to what we had before. But if we go right down to the bottom, there are two new things. So in the previous video, we made a surface. There's our surface. And now in this video, we're going to be constructing a swap chain, and then we're going to be grabbing the images from that swap chain and making a bunch of frames. But in order to construct the swap chain, we're going to need some info about the surface. And you may note here that this surface is a Kronos thing. It's come into mainstream Vulkan, but we do need to request it. So as we go along, you'll see that a lot of these will have KHR in them. That's just how it is. And additionally, in order to have a swap chain, we'll need to request that extension. So if I go over to my logical device creation, and I go right down here, just where I'm requesting the extensions for my logical device, I need to include Vulkan Kronos swap chain. Okay, excellent. So now let me get into the bulk of it. So I'll go over to the swap chain header, and like I said, there's a fair amount. One thing we're going to need to do is we're going to need to grab some info about our surface. So I've gone ahead and made a surface details struct to hold a description of what our surface can support. So we have, this surface capabilities field, which has a number of images and supported image sizes, image extents. We have pixel formats and color spaces are held by the surface format field. And then we have presentation modes. And I'll talk about this a little bit as we get into it. But then I've declared this swap chain class. Now, what I'm doing, the pattern I'm using here, is I'm not using a constructor, because I'll go down to the fields saved in here. We have the number of images on the swap chain. We have the actual swap chain resource itself, the surface format, and the size of the swap chain. All of these fields have default constructors. And the initializer actually takes a fair bit. Here I've just declared that I've got a swap chain. And what this will do is it will jump in and default construct the swap chain. So all of those fields will get pretty sensible default values like 0 or something. But I just want to hold off from calling the constructor until the other resources have been created. Because really, truly, in order to create a swap chain, I'm going to need all these things made. And it's just not possible to have them made at that point in time. And so for that reason, I'm going with this sort of build pattern where we initialize things after it's been constructed. I can already see this is going to be such a great video, very on point, no ranting at all. These are, down below, some of the steps involved in creating the swap chain. And I'm actually going to start with these steps. So querying surface support, then choosing extents, choosing present modes, choosing surface formats. Let's go bottom to top actually. So first of all, I go choose surface format. Actually, all these ones, all these choosing functions. I'll implement these first. So I'll just go over to my source file, get these in. So we'll just pretend that we have been given this surface capabilities thing here. And we're also requesting this like width and height. And so what we can do is we can look at capabilities, and then we've got all of these fields, the minimum size we can support, the maximum size we can support, and all of that. And what I'm going to do is I'm going to look at the current extent, and I'm going to look at its width. And the situation is that when we requested the surface, we told Vulkan what size the surface was, and it went ahead and attempted to construct a surface of that size. So If that operation was successful, then when we later go and get the capabilities of the surface, it should say, hey, you requested a surface of this size, I gave it to you, here you've got it. But if that fails, then it will give us, as a sentinel value, the maximal size for uint32. Then we can go and test that. We can say, well, if we didn't fail, then the surface capabilities should match the original surface size which was requested. So we'll go return current extent. Now if we get down here and this has not been set off, then although we requested some certain size, it just didn't happen. So what I'll do is I'll go ahead and I'll make an extent which matches this original requested size, and then I will clamp that against what the surface can actually support. It's working out the neatest way to write this, but there we go. This is our standard min-max clamping pattern, and we can go ahead and do the same thing . So again, there's a good chance that we created the surface and Vulkan was perfectly fine with it. We can just go ahead and say, yep, there we've got it. Otherwise, we'll have to just be a little careful about our bounds. But yeah, cool. So this is how we would go ahead and choose a suitable extent for a swap chain. Remember that all the images in the swap chain need to be like carbon copies of the surface, more or less, because we're going to blit them over. Okay, cool. So next step is basically our present mode. So there are, I guess, two major present modes which I'm interested in. The first is the most basic. It's called FIFO, first in, first out. And that is, you can imagine your swap chain is literally just like a queue. What we do is we create, these images, we get them queued up ready to present. So, you've got this set of images, pick an image from the set, render to it, put that in the queue ready to be presented to the screen. And if we go really fast and the CPU goes faster than the GPU, we can be filling that queue up faster than it empties. And if we reach a point where simply nothing is ready to go, everything's all waiting to be presented, then we fail, we stop. So this essentially it's the simplest case. It's supported by pretty much every GPU which supports Vulkan and presentation, but it does lock your frame rate, essentially. On the other hand, there's a method called mailbox, and what mailbox does is pretty similar to FIFO in the sense that you have your images, you pick an image, you render to it, it's waiting to be presented. But if you reach the point where you've got no images ready to go, but you've got images waiting to be presented, you can actually reuse an image which is waiting to be presented. So you can it lets you re-render things, and it does not cap the frame rate. So my preference in this case would be to choose FIFO. If FIFO is not available, to choose mailbox. If mailbox is not available, I'll go with FIFO. And that's pretty much what I'll be implementing here. So what I'll do is I will basically look through every element of my vector. And I'll say, okay, if that mode is mailbox, then that's the preferred mode, return it. And then if I reach the end here and for some reason I just didn't get it, then I'll just return FIFO because I know that FIFO is supported by everything. And there we have it. So step by step we are getting there. Next step is to select the surface format, the pixel format for the surface. And now this will go very similarly to the present mode in the sense that I have one preferred format in mind. I'll search for it, try to find it, and if that doesn't happen, I will return a default value. So the default value that I'm going to return is, I guess, just the first format on my vector. That's pretty reasonable, I guess. But as for my preferred format, this is a surface format object. There are two major fields. One is the pixel format and the other one is the color space. So for the preferred pixel format, a lot of options here. I'm going to go BGRA, 8 bits for each, unsigned normalized, and then for the format color space, my preferred color space will be RGB nonlinear. But yeah, there we have it. So basically, the same as before, we look through, we have a preferred thing, we return it, otherwise some sensible default which will always work. The next step that I want to do is querying that surface support. Okay, so what I'm going to do is, in addition to simply getting the support and returning it, I'm also going to be logging some of this stuff out. So I'll go through the usual. And now I'm going to be getting each of these things individually. So first I'll get the capabilities and log them. Then I'll go ahead and get all of the supported formats of the surface. Log those out. And then I will get the supported extents. Sorry, present modes. Blah. Okay, now as for how these things get logged out, I will briefly discuss it, but it's a lot to get into, and it is a good read for seeing how to actually sort of look through these things. So if I go over to the logger, again, I sort of made these in the background because these things really are big, but we go Q families and then surface capabilities. So you can see here that the surface capabilities structure has a whole bunch of fields, all describing pretty much some things that we can do with the surface. And yeah, I'm just going through and logging these things out to the terminal. Not too exciting, but it is a good thing to read through, because yeah. But anyway, so I'll leave that there. Now I'll just go ahead and return the bundle. And now I'm at the stage where I'm going to start using all of this. Okay, so we've mostly got the pieces in place. I'll just sort of bring it together. As usual, I'll grab a logger because we may want to log some stuff out. Then I'll go ahead, fetch my surface support. Then I'm going to, based on that support, choose some things. So I'll get my format. And then my present mode. It's probably worth talking about the difference between these, right? Because some of these fields I am still saving into the class, and some of them I'm just querying them, using them in creation, but not for anything else. And that was just, it came down to personal preference. There are some things that I feel like I may need to use in future. For instance, image count, even though I'm not using it for anything, I'm thinking that's a useful thing to have. There we go, we'll keep going. So we'll then get the extent. Then I want to get the image count. Okay, so what I'm doing, okay, so what I'm doing here with adding one is I'm just giving myself a little bit of overhead. So let's say, for instance, I mean, I don't think this actually happens, but let's say that I go and I create my surface and my surface says, hey, I support a minimum image count of 1. It's like, great. But if I go ahead and have my single buffered system, I'm not necessarily going to be getting the most horsepower available, because there's a pretty strong chance that, well, I'm just not going to be able to tee up those operations as quickly, sort of the render and present working at the same time. So just in order to give myself as much flexibility as possible, I'm selecting the minimum number of images plus 1. But yeah, so now I'm going to go ahead and create the Swapchain, or make the Swapchain create info. And the way this works is we go Vulkan, and there's a whole bunch of things we can put in here, as we can see. And what I'm going to do is I'm going to put some of these things in, but then you'll see that some of them have default values. So for instance, these first few, we need to put them in. We need to put in some flags, we need to put in a surface, minimum image count, all those things. But then as we get later on, for instance, the pre-transform on the Swapchain, there's a default value of the identity, so we probably don't need to put anything there. Composite alphabets, default value of opaque. Yeah, I mean, as you can see, some of these things have defaults. So anyway, bearing that in mind, I'll go ahead and construct this. Okay, so we've got our surface. We'll then need to put in our minimum image count, which will be actually the image count field there, and then the format. The funky thing here is we need to access the format of the format, and then the color space, which is the color space field of the format. Then we'll have the extent and the image array layers. We're just going to have one. Image usage, it'll be used as a color attachment. Sharing mode. Sharing mode is going to be exclusive. So what this is doing is, if we have multiple queues which are using the resource, then we've got either concurrent or exclusive mode. Concurrent mode is when different queues are concurrently using the resource, and exclusive is when one queue has exclusive access to that resource. But yeah, so exclusive. And now I'm going to go ahead and I'm going to set a bunch of other flags, a bunch of other options, sort of independent of this. I should probably save this to a variable. So it's just a fair bit of typing there. Okay, so finally, I'm going to create this thing. And I'll use the same pattern that I have been doing for everything else, which is, because I'm doing no except, I'll go ahead and what I'll also do while I've got this set up is I will record the deletion function for the Swapchain. So because the Swapchain was created by the logical device, it will go on the device deletion queue. The device will be responsible for deleting it. There we go. Okay. But otherwise, I'll just print some sort of error message. Now an overview of sort of how this code is going to get used. When we go to our renderer and we've created everything else, we've made the surface, logical device, all of that. Then first of all, what I'm going to do is I'm going to query the size of the GLFW window because I didn't pass that info in. It's fine, I can do that. Then I will go ahead and construct my swap chain based on all the info that I set up above. Once that swap chain is created, I can then get a vector of images from it using get swap chain images, and then I can construct a frame for each of those images. So think of it as we've got the swap chain. The swap chain is a bunch of images which will be presented to the surface. But then I've got copies of those images sort of in a convenient form that I can access. That will also help me, it might be a bit much to talk about now, but that will help me later on when I've got additional resources that I need to give them a lifetime, which is on a per frame basis. Anyway, so let me go ahead and run this. That's fine. I'll just go and reconfigure my CMake. Cool. All right. So I've got my window as before, printed out a bunch of info. I'll talk about that in a second. I can close, and thankfully there are no errors and things are being deleted in a sensible order. So I'll just bring this up and have a look at what I've got. So up above I went through, this is all my graphics queue querying stuff, but then I want to look at the swap chain. So capabilities that my MacBook M1 can support: have a minimum image count of 2, max of 3, okay. Current extent, now this is an interesting thing. So originally I created a window 800 by 600, but I guess this is I think it's a max super resolution thing or something. It's actually double the number of pixels. That's fine. We can support a minimum size of 1 by 1 and a maximum size of something very big, like 16,000 pixels. That's so much. Okay. We can only support one array layer per image on the surface. This may not be too exciting to hear me read through my capabilities one by one, but the point is the logging function works. We've got all this stuff, and this is interesting actually, things we can use the surface for. We can sort of transfer to or from it. We can sample it, so we can sort of use it as a texture. We can use it as a storage image. We can use it as a color attachment. And then you can see all these different pixel formats and color spaces we can use, as well as, interestingly enough, it looks like we don't have mailbox supported. That's very interesting. Anyway, that's fine. So this has just been a little tour through swap chain creation. We are slowly getting there. And yeah, okay. So that'll be it for now, and I will hope to see you again soon. Bye.